explorers, and welcome to another video. Today we are going to tackle day 5 of the advent of code. So let's just switch over here and let's see what today entails. You come across a field of hydrothermal thermal vents on the ocean floor. These vents are constantly producing a large opaque clouds, so it would be best to avoid them if possible. They tend to form in lines. The submarine helpfully produces a list of nearby lines of vents, your puzzle input, for you to review. For example, and then we have a bunch of lines here where we have x and y coordinates. Each line of the vents is given as a line segment in the format of x1, y1, x2, y2, where x1 and y1 are coordinates of one end of the line segment, x, y are the coordinates of the other end. These line segments include points at both ends. In other words, an entry like 1, 1, 1, 3 covers the points 1, 1, 1, 2, and 1, 3. An entry like 9, 7 to 7, 7 covers 9, 7, 8, 7, and 7, 7. For now, only consider horizontal and vertical lines where either x is equal to x1 is equal to x2, y1 is equal to y2. So the horizontal and vertical lines from the above list would produce the following diagram. This diagram in the top left corner is 0, 0, and the bottom right corner is 9, 9. Each position is shown as the number of lines which cover that point, or dot if the line no line cover that point. The top left pair of ones, for example, covers 2, 2 to 1, 2. The very bottom, to avoid the most dangerous area, you need to determine the number of points where at least 2 lines overlap. In the above example, this is where the diagram with 2 or larger, a total of 5 points. Consider only horizontal and vertical lines. How many points do you have at least 2 lines overlap? Yeah, so let's get into this. First off, I think I will create a byte array, because now we are talking about a large amount of numbers or a large amount of positions, but not that many numbers. So let's see, here we have a byte array. So this is the map, which we say is byte 1000 times 1000. And you might wonder, why do I choose 1000 times 1000? Well, I looked at the input data and realized that if we look here, none of these values are above 1000. So I did a quick check there and realized that everything was below 1000. So 1000 by 1000, we almost have a megabyte of data here that we need to handle. That should be fine, I hope. So now we need to figure out how to handle a line. So let's create a Java class called line, or just say line segment, like that. And here for each line we will create a new line segment with this line. So we have it in here. So one ls there, a line segment. I guess I can do a var. Be a little bit naughty and use a var here. I usually don't use those. Like that, and then we can take ls map. So we will map it on the map, like that. Create that method. That will put things on the map. And last but not least, we will take the map, so for byte b in map, go through all of those, and if b is more than 2, then we will take the count and add to it. So an int count starting at 0 here, and then we will take this count and print it out. So now we have pretty much all that we need. Now we just need to handle the line segment here. So the line segment, that should have a bunch of values here. So x1, x2, y1, y2, like that. And then we will take this line. Let's take one line part here, so we just can see it. So first off, we need to split this into coordinates. So string coordinates equals to let's do this and take line and split it by the arrow, like that. Then we should have 2 coordinates, and we will take coordinate 0 and split that by and we will call that positions, and we will take position 0 of that, and integer parse int of position 0, that should be x1, and then we do the same for, so we have the y position here. Then we will pretty much do the same here with the y and x2. So now we will have all those values like that. And now we need to map these. And they might be that we have x positions that goes up, we have y positions that goes up or down, which could make this a little bit more interesting, so to say. But let's start with figuring out if x1 is equal to, not equal to x2, and y2 is not equal to y1. Y1 is not equal to y2. Then we will return. So if we have the case where both of those aren't on the same line, so we don't have this where any of them is equal to each other, then we just return, we will not map them. Now we need to figure out how to map different things depending on if they're going up or down. Let's say that the x coordinate is equal if x1 is equal to x2, we do one thing, else if y1 is equal to y2, then we'll do another thing here. And then depending on if we're going up or down, we can handle them the same. We just need to figure out which of the values are the lowest value. So here we can pretty much take for loop of let's have I equals to math min of y1 y2, and then we will go until math max of these two, and then we'll do an increment here. So that's one thing we can do in that case. In the other case, we will do similarly with our x values. Pretty much. And then depending on if we are doing x or y, we're doing a little bit different here. So map, I think we need to do one more thing later on, but I will try to remember that. So y1, oh, the y value is different. So here we will take 1,000 times I plus x1, for instance, and we will add to that. And down here, we will take y1 plus I, and then change that up. So that's our mapping function. What we need to do now is also go in here and do arrays, fill, map with 0. Can't we do it for byte? Yeah, okay, so it need to be a byte, of course. Let's do that. So, if we run this now, what do we get with this code? We didn't run the right example here, so let's run day 5. We got 0. So that's not correct. So let's start by debugging a bit here. We go in here and we will debug this line segment. We will get some coordinates here, x1, y1, and then x2, y2. Yeah, so that's pretty much it. If we go in here to the map, they are not similar. And here the y values are equal, so we will go through and put in values. So our map should have some values here. We could do this a little bit smaller in the first case here, because we know that the first ones are just 10 by 10 squared. So let's make it easy for ourselves and not make the map too large. Yeah, so then we need to change these as well. So we can do private or public static final int map size 10. Do that, put that in here, and then we do like that. Use line segment of map size. So we only need to change it one place, like that, and we still got 0. So let's continue here. We will go in, and now I think we will do this. So we go down here and go in, and so from 0 to 9. So first off, we have the value 0, and then we should put something. One value here need to be at least 1, yeah. So we will put in some values here. That's correct. But wait a minute. I did something wrong here. At least 2, so larger than 1, right? Then we got 2. Oh. So let's see here. How does our map look? So 2 values have the value 2 in them. so we need to change our function here a little bit, because we need to go until they are smaller or equal. Because we will go to that point as well. So we move a little bit longer here. Then we got 5. So that was correct. We don't, because before I went, for instance, in this case up here somewhere, where did we have that? Where they want to go from 2 to 1. I didn't do the last one. I only did the first the value. Here we have 1 1 to 1 3. Then we took 1 1 and 1 2, but we didn't take 1 3. So we didn't take the actual last point. So we need to have an equal here as well. So let's switch this up. Change our map size to 1000 again. And see if we can run with the full example data here. Jesus, this is gonna be interesting. Then we end up with 5,632. So let's put that in and see what we get. Yes, you get a gold star, I get a gold star, everybody gets a gold star. Nice. So let's see. Unfortunately, consider only horizontal and vertical line doesn't give you the full picture. You need also to consider all the diagonal lines. Because the limits of the hydrothermal vent mapping system, the lines in your list will only ever be horizontal, vertical, or a diagonal line at 45 degrees. Thank you! At the entry, cover a point of that considering all lines from the above example, you can now produce this kind of thing. You still need to determine the number of points where at least 2 lines overlap in the above example. This is still anywhere in the diagram with a 2 or larger, now a total of 12 points. Consider all of the lines. How many points? At least 2 lines. So this is good, should be relatively easy. Last famous words. So let's see here. Go back here. So now we just need to remove our return case here. And we need to handle the last else statement here. So the hard part here is that we could have lines that go in either direction, which is a little bit bad because we don't really know what the middle case will be. I wonder if we can do it as a lambda or something like that to make it easy for ourselves, or else will be a lot of if statements. That could work as well. So let's see here if we have y1 if y1 is larger than y2 and x1 is larger than x2, then we want to go from in that direction. Let's start with the first easy case. Then we want to go from then we want to have a start position of y1 and we want to have an end position of the one y2 in the y-axis, which means that let's do a bunch of for loops then. Y equal to y1 and then we go to y2 y++. Wait a minute, wait a minute. We need to have only one of these, right? Because they are 45 degrees, so they can only go from one point to another point and end up at the same value, which makes things much easier. So let's see here. If this is the case, where we have here, then we will take map size times y1 plus I plus x1 plus I. So that's what we need in that case. Else, if we have that case where both of them are less, then we just need to do minus here. No. Wait a minute. Then we want to go from the higher value in both cases and back again, down. So then we only need to change these two, right? Pretty much. So now comes the little bit more advanced things here. Now we just need to keep track of which one to do. So in this case, we want to do x2 plus I. Nope. x1 minus I. That's what we want to do. And in the last case, when we have this, we want to start at x1, go to x2, do minus there, plus there. Oh, so many strange things. I think I actually need to print this out. For I equals to 0, I smaller than 100, I plus plus. Then we do map I print like that. And we don't do print line, we only do print. If I is modulus 10 equal to 0, then we do a system out print line. Can that work? Perhaps? Will we get a bit of a map then? Index -1 for bounce 100 doesn't work. Yeah, I understand that. Y2. If Y1 is larger, let's see here. Y1 is 5, Y2 is 1. x is 5. Oh, now that doesn't work. Of course it doesn't. We only want the length, of course. So 0 until that. 0 until that. And then here we do 0 until the length. And up here we do 0 until the length. So why did I get extra down here? Yeah, print count 11, I guess. So they got 12, I got 11. So the first line here looks promising, but one value is wrong. Why? So let's go through each of these and check how they should work. So here we want to go from 8 until 8. And then the first value here, we will have 8 on x1 and 8 on y2. Yeah, so we start by 0, 8, 0, 8. So we start at this position, and then we should draw down to that position. So that seems reasonable. Let's continue to the next one. Here we have, let's see, 4 is larger than 0. So that's correct. And 6 is larger than 2. So the first value we will start with here is what? So both of those values are larger. No, that will not work. If we want to do that, we should have minus minus here, right? Because in this case, we are starting from the highest value and then going backwards, right? Let's see here. So I would like to see these values. Don't really know why we got these values here, but add more. Four, 6, 5, 3, 2, 4. Yeah, so then we go down to the other value. So that seems reasonable. And here we only should go up because we have both of these values are lower. So we just go from 0, 0 to 8, 8. What? No, of course, plus, yeah. So that will just work. No problem there. And here we have x1 is larger. X1 needs to go down to x2. X1, y1 needs to go down to x2, and x1 needs to go up to x8. So that works as well. Yeah. So yeah, this should be fine now. So now we got 12 as a result, and the map seems similar. Yeah, seems exactly the same. So the last one we can't really draw the map because that will be not intelligible because it's too large. But we should at least be able to run this, of course, because now we have validated that all the different functions are correct. We only need to run this. So let's see what we got as a result here. 22,213. Is that correct? Yes! You get a gold star. I get a gold star. Everybody gets a gold star. So we solved that one. When I read that we only should consider vertical and horizontal lines, I was actually a little bit prepared that the diagonal lines would be integrated in the next step. But you never know with these puzzles, anything can happen. I hope that you found this interesting. I learned a lot today by handling coordinates and so on, a lot of debugging again. But I think I have a larger grasp on how to actually go up and down in coordinate systems and actually draw lines. Even if it's just 45 degrees, you can have a little bit more appreciation for it. If you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. If you want to comment or share your code, leave a comment in the comment section down below. And I really hope to see you in the next video.